In the tutorial you just saw, we created a linear regression model, two of them. They both had the same result. And we use that to predict the expected cost of a spacecraft based on how heavy it is. So its cost as a function of weight. But how good is that model? One way to evaluate the goodness of that model is with an R-squared, but an R-squared is a little bit abstract. That doesn't necessarily tell you what sort of error you're going to see if you use that model to predict it, predict the values. And so standard error is a way of predicting in the same units that you're working with what sort of accuracy you can expect with your model. So let's say that we have the data here, the same data as original. We know the spacecraft weight in pounds, its actual cost. Well, what cost is predicted based on the regression model from before? So if we use this equation that we had before, let's type in and find out what the expected or predicted cost would be. So the cost is going to be 0.8134 times the weight minus 122.96. And so we're actually using that model now. And so, for example, a spacecraft that should weigh 400 pounds, the actual cost that we know based on the data we have is 278, but using our model would have guessed that it was going to cost 202. So for each of these predicted values, what we're doing is we're substituting in the weight into our function from before and finding out the predicted cost. So now, in this formula, to calculate the standard error, it says that we need to have this, the difference between the predicted and the actual cost. And so that's what I'm going to do in this column, equals the predicted minus the actual. All right, so we have, oh, I'm sorry. Well, it doesn't end up mattering because we're going to square it. You can see that here I've got actual minus predicted, and up here it's the reverse of that. Since we're squaring it, it doesn't matter which comes first. So we drag that down. And we know all of the actual minus predicted costs. Here, we're going to square that. All right. Oop, not there, though. Okay, so we've got the square of all these. And so this now says we want to take the sum of the squares. And so equals sum of all of these up here. All right. And now the standard error is the square root, SQRT, of the sum of the squares divided by n minus 2. n was 6, so n minus 2 is 4. Alright, so what that means is that when we use this, we use this model with the data that we have, the average, or the standard error, the error that we can expect to see, is 109.64, the difference between actual and cost. Now, that's not the same thing as the average of these. It's a statistical measure of model quality that takes into account the size of each of the values. So that's the manual way of calculating the standard error, and you can do that on paper. You don't have to use Excel to do it. One of the advantages of using Excel, though, is it has functions that oftentimes can take some of the work out of your hands, and so that's the case with this formula here, STEYX. And so one of the nice things about Excel is when you start to use it, it'll prompt you for what data you should type in. So equals, and I'll demonstrate it, STEYX. And so as you type it in, you can see that it's telling you it returns the standard error of predicted Y value for each X in a regression. So when we put that in, it's going to prompt us the known Y's, and so Y values are what comes out of the model. That's the dependent variable, and what comes out of our model is the cost. And so it's for we put in the actual cost, the known Y's, so we highlight the known Y's, then we do comma. Now it wants to know the known X's. So the independent variable, what goes into our model, is the weight. So this is the range of the known X's, and that's all. When we close that out and press enter, what it's doing is it's first creating a regression model, and it's evaluating the standard error of that regression model. It's kind of interesting. In this function, it doesn't even need us to tell it where the predicted data is because it's doing that itself. Press enter, and you can see 109.64. So those are two different ways that you can calculate standard error.